Unlike ancient philosophers imagining the universe's origins, modern cosmologists use quantitative tools to gain insights into the universe's evolution and structure. Modern cosmology dates back to the early 20th century, with the development of Albert Einstein's theory of general relativity. Now, researchers from the Atacama Cosmology Telescope, ACT, collaboration have created a groundbreaking new image that reveals the most detailed map of dark matter distributed across a quarter of the entire sky, extending deep into the cosmos. What's more, it confirms Einstein's theory of how massive structures grow and bend light, over the entire 14 billion-year life span of the universe. We have mapped the invisible dark matter across the sky to the largest distances, and clearly see features of this invisible world that are hundreds of millions of light-years across, says Blake Sherwin, professor of cosmology at the University of Cambridge, where he leads a group of ACT researchers. It looks just as our theories predict. Despite making up 85% of the universe and influencing its evolution, dark matter has been hard to detect because it doesn't interact with light or other forms of electromagnetic radiation. As far as we know, dark matter only interacts with gravity. To track it down, the more than 160 collaborators who have built and gathered data from the National Science Foundation's Atacama Cosmology Telescope in the high Chilean Andes observe light emanating following the dawn of the universe's formation, the Big Bang, when the universe was only 380,000 years old. Cosmologists often refer to this diffuse light that fills our entire universe as the baby picture of the universe, but formally, it is known as the cosmic microwave background radiation, CMB. The team tracks how the gravitational pull of large, heavy structures including dark matter warps the CMB on its 14 billion-year journey to us, like how a magnifying glass bends light as it passes through its lens. We've made a new mass map using distortions of light left over from the Big Bang, says Matthew Madivaccherel, assistant professor in the Department of Physics and Astronomy at the University of Pennsylvania. Remarkably, it provides measurements that show that both the lumpiness of the universe, and the rate at which it is growing after 14 billion years of evolution, are just what you'd expect from our standard model of cosmology based on Einstein's theory of gravity. Sherwin adds, our results also provide new insights into an ongoing debate some have called the crisis in cosmology, explaining that this crisis stems from recent measurements that use a different background light, one emitted from stars in galaxies rather than the CMB. These have produced results that suggest the dark matter was not lumpy enough under the standard model of cosmology and led to concerns that the model may be broken. However, the team's latest results from ACT were able to precisely assess that the vast lumps seen in this image are the exact right size. When I first saw them, our measurements were in such good agreement with the underlying theory that it took me a moment to process the results, says Cambridge PhD student Frank Koo, part of the research team. It will be interesting to see how this possible discrepancy between different measurements will be resolved. The CMB lensing data rivals more conventional surveys of the visible light from galaxies in their ability to trace the sum of what is out there, says Suzanne Staggs, director of ACT, and Henry DeWolf Smith, professor of physics at Princeton University. Together, the CMB lensing and the best optical surveys are clarifying the evolution of all the mass in the universe. When we proposed this experiment in 2003, we had no idea the full extent of information that could be extracted from our telescope, says Mark Devlin, the Rees Flower Professor of Astronomy at the University of Pennsylvania, and the Deputy Director of ACT. We owe this to the cleverness of the theorists, the many people who built new instruments to make our telescope more sensitive, and the new analysis techniques our team came up with. ACT, which operated for 15 years, was decommissioned in September 2022. Nevertheless, more papers presenting results from the final set of observations are expected to be submitted soon, and the Simons Observatory will conduct future observations at the same site, with a new telescope slated to begin operations in 2024. This new instrument will be capable of mapping the sky almost 10 times faster than ACT.